Okay. Welcome, welcome, everyone. All right. Let's get some beverages going and see where we left off. Uh, give her a run. All right. So far we have our guy moving one step. Perfect. Let's open up our IDE and see what's going on. Of course, this is going to take 5 minutes. Come on. You can do it. There we go. Got Ryder opening up somewhere. Hello? There it is. Bring this guy over here. All right. So let's see. We got a camera. Do some Q&E stuff to rotate. We've got a cell. Change its colors. We've got a board. Do some other highlighting. This is going to be a representation of our board. So this is the logical representation, right? These are just coordinates that are all integers instead of like world coordinates. But, you know, make it easier. We're going to map these to world positions too. And we've got our main game class going. So when we start up, we build our board, set up our enemy, our player, set up our enemy, point our camera at our player, move the enemy, move the player. We've got a dock around here somewhere. Yeah, there we go. Let's make sure we got everything going. All right, so we're going to do a spooky haunted house escape. Some of the rules, we're just going to have a square grid. We're going to have players, and then the enemies. I guess this could be more clear. Ghosts, skeletons, and monsters. Each turn, player is going to roll a dice to pick a monster type, and then move that many spaces to move that monster. So let's say we have a d6. Let's build this guy out. Enemy die is a d6, right? So each one will have two spots, two sides for each monster, two move amounts, right? Yeah, sounds good. So we'll have like the ghosts, you know, can move, you know, 2 or 3. Skeletons can move 3, 2, 3 or 4. And then the monsters, these guys are going to be should we make them the fast ones or the slow ones? Let's make them slow. Yeah, let's do 1 to 3. You know, a little more variable. 1 or 3, so these should be slashes instead of dashes, right? We don't want a range. We want, those are the options. So the player moves the monster up to that many spaces, right? If the monster stops on a player, then during that player's turn, they can't move until the monster gets moved off them. Or we're going to have some cards. So they can play a card to get out of dodge, escape from the monster. Then it's the player. They can move 1 space if they don't want to do anything else. If they're not on a monster, or a monster's not on them. They can play a card, and a card can be, you know, move extra moves, escape from a monster, or they can do a discard and get new cards, and then pass. I don't know why you'd pass. Discarding seems like a good idea, but we'll play test that later. In your hand, you can hold 4 cards at a time. When your turn ends, you restock up to 4. We can move cards, you know, move 2, move on a speed tile, you know, like I was thinking like carpets, you know, you can move, you're a little more comfortable moving around a haunted house on a carpet because it's quieter, right? So, get a little faster movement on there, or, you know, escape a monster card. And that's what we got so far. And then our entities, you know, we have a board, which is our grid, player, an enemy, something about dice and cards. You know, we'll have to figure these guys out too. So that sounds pretty good. We got the board going. We've got an enemy or a player moving. Let's see what is up next on the docket. So move the enemy, move the player, and we only do that once, right? So we're only calling these guys once. So what could be the next piece of the puzzle? Oh, I'm getting pop-ups where I have poor stream quality because no idea how to set this up. See if we can poke at this for a moment and get it going a little better. Where is should be streaming at like 1K. Does that sound right? I'm going through my stream settings because, you know, this is the perfect time to do it. Start streaming, then fix everything. We're recording audio, video. Oh, yeah, probably scaled this guy up too much. I don't think I can fix it while I'm streaming. All right, well, if it looks awful, let me know and we'll try and fix it. Yeah. Anyway, let's keep moving, and maybe you'll just upload the locally recorded version later and play it off as it all worked. All right. Excuse me, gotta take a sip of water. So we move the enemy, we move the player. Let's get this into like a sequence, right? So we move our enemy, we move our player, and then we're gonna move, like, the next player is gonna go. So we can add a couple of players, right? So let's say we do player 1, game object, player 2. Let's have 2 players for now. And then let's leave 1 enemy. Yeah, both players are going to move the same enemy. Yeah, that sounds right. Player 1 starts. Let's start up some sort of loop, you know. So we want to do something like, you know, while true, you know, loop, you know, do all the turns. Tap these guys out, move this guy down, fix the formatting. But this is a blocking call. So when Unity calls start, it's going to block. So what we want to do is we want to be able to yield execution, and we can yield inside of a coroutine. So let's do, that's not ping, let's do a coroutine. Public I enumerator, let's call it turns, run game, do turns, and then this is just going to yield return for now null, so it'll do 1. And then let's do this guy in here. I don't know why we put that in there. Do enemy, do player, yield, return null, you know, skip a frame. Let's start coroutine, do turns, right? So now this will fire up and it'll loop through these guys. And it's going to do move the enemy, move the player. But this move enemy, oh, we got to fix all this stuff now. Because we renamed it. Should have refactored it, but there we go. Move enemy is right there. All right, so get moves, highlight, selecting chord. Let's swap this guy out. So like this is hinging on this Boolean. Let's see if we can get it to wait, because we want to highlight the board, right? And then we want to wait until. We're going to keep looping until the player selects where the enemy is going to move, right? So we need to turn this into coroutine, right? So let's do move enemy as a coroutine. So this is going to be like everything turns into a coroutine. Isn't that fun? I enumerator, move enemy, and then let's say get the moves, highlight the board, and then I'm trying to figure out what we did. We add a wait to call. Oh, this is an action. All right. So until that comes back true. Oh, this is the complexity spike. Yeah, I don't know what's going on with my stream health. Figure it out later. move enemy. So we're going to set it up. We're going to highlight the board, and then we're going to wait. We're going to wait until something gets selected, right? So while we could do another coroutine here. Yeah. So move enemy is a coroutine. Start coroutine, move enemy. Oops, that's not the button I wanted. Right, and then this will keep going until it yields, or until it, oh yeah, until it returns something, right? I think my coroutine stuff is now coming into question. Let's throw a yield return null. Or do we have to return a value? Because this is going to return a coroutine. I think this is actually a yield, right? Yield return wait until start coroutine. It's a new. No, it's not a new. Wait until start coroutine. This is getting messy. Start coroutine. Move enemy. Right. Let's cheat a little bit. I figured this out earlier in the week. We'll get some quick answers that way. See if we can open up some cheaty stuff I already did, because it's always okay to reference your own work, but it's not okay to steal others. Game this is the wrong folder. Unity projects. So I was messing with this. So coroutines, when they return, like when you start a coroutine, it will return the coroutine, and you can ping off of what the return is. So you can return true and false from it, and then you can wait. You can wait until like a true, like until the statement becomes truthy, and you just have to keep returning false until that sub coroutine is done. And I thought I had it down, and then everything explodes. There. Let's choose this guy. All right. So here's my just messing around code. Yeah, it is. I was should have just gone with it. Start coroutine, and then come on, writer, keep up. Pick monster, yield return null. Yeah, this totally just loops until this coroutine finishes. So this will now, so this yield will sit and loop on this coroutine until this coroutine exits, right? So if we get rid of this guy, go into move enemy. So if we loop in here, new wait for seconds, like 40. So our execution path will go down and say, all right, we're gonna start this coroutine, do turns, and then this one's gonna get into this loop, and then it's gonna yield return, and it's gonna keep executing this until this move enemy finishes execution. So the wait until in here will block, essentially. I mean, it'll keep coming back here and going back and forth, but it'll essentially block and not continue execution of this coroutine until this coroutine completes. So we are going to do something like this. On selected cell, we are going to do move enemy. Let's do this. Selected cell is an action. Oh man, I'm like totally not having a good night. All right. If we have this selecting coordinate, right? So selected cell, we can plus equals cell coord, and then do move enemy. Let's put something in here. Private vector3 int selected. See, we want something like this, but we don't want the action. Like last selected cell, right? That could be all right. And then we can do in here move enemy. We can do a yield, not break, yield return new wait until, and we can say like selecting coord equals false, right? Wire bool, not system func bool. Okay, just need to make it a function. There we go. So this is like a lambda notation. So this will sit here until selecting coord is false. So let's say selecting coord equals true. Yeah, true. Like we're starting to select. Get rid of this guy. So once it turns false, we'll continue execution. We'll figure out this bit in a minute. So once it's selected, we can continue on and say do move enemy, last selected cell, right? And so like while we're waiting for this will just keep sitting here and looping and giving up execution, and then we can go back and do like this guy. I'll do this stuff. So board clear highlights. So this do move enemy. This is the callback hell that we're we're getting into. So do move enemy. Let's turn this into, what is this guy doing? This is removing. Oh, this is just straight up moving him. So this will block, set the enemy, clear the board, return. I think we're okay there. And then this will return this, move enemy will return up to here, and then we'll do the player. All right, let's jump into here. So in game, we're gonna have, if we're selecting the coordinate, so we're selecting a coordinate, right, true, this will start executing because we're yielding. It'll do a whole bunch of stuff, boop, boop, boop. Selected cell, we're not gonna do that. We are gonna do last selected cell is cell coordinate, and then selecting coord equals false, right? We're collapsing, not float, false, right? So this is going to keep looping because it's update, right? And it's going to keep looping until we hit selected coord false, which will stop this loop, but it will also allow this execution to move forward. When that moves forward, we set this at the same time we set that, and we move the enemy, move on with our lives. This will return, move enemy will jump up and return from do turns, and then we can move on to the player. And let's do the same thing. Yield return, start coroutine, move player, and we're going to turn move player into a coroutine. Public enumerator highlight, and this is going to be very samey, and we'll collapse it down in a minute. So we've got move enemy here, move player. We're going to update these guys. So get moves for the player, highlight the moves. Then we're just, you know what? We're gonna steal this. Steal this stuff. Because we're going to do it the exact same way. Selecting coord is true, wait until it's false, and then we're going to do move player and the last selected cell, right? Because this won't clear until this gets set. Boop, boop, boop. Great. So move player, select false, that'll return execution back up to here. This will wait a frame, and then it'll go back, because this is, while true, start coroutine. It'll do the enemy. So hopefully it'll highlight the enemy moves, we'll select a move, it'll highlight the player moves, move the player, and it'll just keep going back and forth. Whew, that was a lot. And we get to wait for it to compile. So let's take a drink. flavor adjacent water. Delicious. And we get to wait for more progress bars. Awesome. All right, so this should be the enemy. What do we do the enemy as? I think the enemy is the square. So move the enemy. Oh, it's a zombie. And now when we click this guy, it should move the player. Boop. And now we're back to the enemy, right? Well, and now we're alternating, right? So player moves, enemy moves, player moves, enemy moves, player moves, enemy moves. This is a board game. We got it. All right. Dunzo. See you later. Just kidding. Great. That is pretty awesome. How about we make it a little more interesting? So these guys snap. Yeah, when we move them, we just snap them. How can we make that more fun? Or do we move on? Let's move on, because more like animations we can add later, right? So when we do this move enemy or do player, we can turn these into coroutines, right? And then say like, hey enemy, do your moves in a coroutine, and then just it'll yield execution when that animation is done. Same idea here. We'll yield until either animation done, or we'll yield until a coroutine is done. So I think this is okay for now. Let's add more board space because I want to add more enemies, right? So we have one player. Oh, we have one player. We want multiple players. Wow, I'm all over the place. Let's go back and forth. This is a good time. So the move enemy and the move player are nigh identical. The only difference being like this, the game object that we select, and which method we call, right? But do move player and do move enemy, we can get rid of this and do move player. Clear. It's selecting core. We can get rid of this guy. Oh, look, these are also identical now. So we could probably collapse these guys because the only difference is the game object. So let's say, right, game object. Let's say game object. Whoop, oh no. To move, and then we can pass that in and just say object to move. Do it, and we're always going to clear the board highlights, right? Someone moves, it means we selected. We're going to clear the highlights, and then do move. What should we rename this to? Do move pawn? Are they pawns? Do move. Do move. Do move sounds good, right? All right, let's refactor it. Let's do it the smart way this time. F6, do move, done, boop, great. So now that we have one, I'm gonna get rid of the do move enemy, and this will get angry and say do move, right? And then we have to pass it. This is the enemy, right? So we have the enemy game object. That's gonna do that. This is the player. We're gonna say let's hardcode player one just for a moment. And now these guys are. I'm just gonna copy and paste them up here. So move enemy and move player, again, pretty identical. The differences being this game object, right? Because we're just passing it in. This is internal. This is internal. This is same thing. Oh, are we seeing a pattern here? I think we're seeing a pattern here. So we're going to say do move enemy. Let's do the player one. Do move player, and we're going to pass the coroutine game object to move, right? And then we're going to get the options for there. And then instead of that, we do this, right? So now this is no longer dependent on, the player one, player two. It's only dependent on this guy, because if we click this, right? So this is dependent here. This is created here. This is, set globally. We can fix that later. But it cleans this up. And now we can just call this... we've already got a do move, right? Oh, you know what? Okay. Now since this is so simple, right? It's just we're always going to use this in the same way. Let's just move this guy up. Let's just take this logic. We're just going to dump it in there, right? And then this is going to be last selected cell, right? So now this doesn't matter. Let's collapse this down. Move enemy. We're not going to use anymore, and this is just going to be now do move, right? Let's see where else. Do move, and this was the player, right? So we pass player 1 in, right? And then this is going to be do move enemy, right? We just have one enemy for now. So now we have a generic, should be the same functionality, right? Let's go give it a test and wait for compiling. Take a little sippy sip. I can hear someone whispering lime in the other room. It's good stuff. Do a little reload. Now we should see pretty much identical functionality, right? But we collapsed quite a bit of code. See if we can get these on the same cell again. Yep. So we have to do that. We have to exclude. Well, I guess enemies can move on to players. Players can't move on to enemies. Or would you want to do that? Would you want to be able to move on to an enemy to block yourself? Yeah. That's a playtesting update that we need to do. Cool. So we've got our one player, our one enemy. We've got a nice, do move. This is generic. We can move anything. Let's do player setups. So this really only just instantiates the player right at the start position. How do we want to make this better, right? So this function is really set up player 1. We want to be able to set up any player. This is set up enemy. I think we're calling him zombie for now. Looks a little zombie-like. But we've got 2 players, so let's do the same thing. Let's break this down. Not break it down. Let's collapse this down. I'm gonna get rid of setup player and just drop that in there. So player 1 and player 2, right? Just copy pasta that guy. Player 2, he's going to be the same idea. He's still going to be a prefab. We're still going to drop him at the start position. And then we set up our enemy. Let's collapse this again. So we can move this stuff back out later. All right. Set up enemy. Position stuff and player. That's good. Good word. So now these guys, we could get rid of them. Not used anymore. We're just deleting code tonight. Because no code is good code. So we have player 1, player 2, and an enemy, right? So now we're only doing player 1. So how about we do a list of players, right? So we're gonna increment our players. So we do player 1 gets a turn, player 2 gets a turn. But when player 1 takes his turn, player 1 moves an enemy, then player 1 moves themselves. Then player 2 moves an enemy, then player 2 moves themselves. So let's see if we can stick the players into a list, right? And we can just iterate over that list, because once we hit, the last player and the next person is the first player. So do a nice fun, what is that called? Looping? Not looping. Modulus thing. There's a term for it, but you use modulus either way. Game object, we'll call it players, right? Start up, set up the players. So players equals new list of game objects, obviously, and then let's just implicit these guys are it's player 1, player 2. I don't like dealing with player 1, player 2 anymore. We can refactor these to be better named, or better, more easily named, right? So we're just setting up a list with 2 players, do some formatting. And then let's see if we can rename this. So this is no longer going to be player 1. This is players index 0. Ooh, nope. I tried. All right, Ryder. That's okay. Let's do it the old-fashioned way. So player 1 to transfer. So this is where it's referenced, right? So let's get rid of player 2. See if he's referenced anywhere. Just player 1's going. Okay. So we're using player 1 in start, right? This is just going to be whoever the first player is, right? And then we can do player 1 here, but we're going to do an integer to represent private int cur player turn, current player's turn, cur player turn. Abbreviating has never hurt anyone before, so let's initialize this somewhere else. Current player turn equals 0. You know, maybe set this up some other way so like player 2 can start. And then do turns. We're going to do, instead of player 1, doesn't exist anymore, we're going to do players and then cur player turn, right? So a turn is, this is all turns, right? So we're going to move an enemy, and we've only got one enemy. We'll fix that later. We need with stimulated to pick one if there's multiple, and then we're going to do the player move. So whatever the current one is, right? And we can probably just get rid of that frame count. And then once this player's done moving, right, we can increment. Cur player turn equals cur player turn plus 1 modulo player's length, right? Count. All right, count length, same deal. Let's just, you know, be fancy, throw some parentheses in there. So now, right now we have 2 players, right? So two players is count 2, right? Current player turn is 0. 0 plus 1 is 1. 1 modulo 2 is 1. Current player turn is 1, which is the second player because, you know, lists start at 0. Then the next time through, right, cur player turn 1 plus 1 is 2. 2 modulo player's count, which is 2, is 0. Cur player turn becomes 0, right? So that's how we loop around. And that should do it. We're compiling. Let's give her a test after we rebuild assemblies. That is some lightly flavored water. All right, we're getting there. So getting there. All right, player 1 moves the enemy. Player 2 moves. Player 1 moves. Player 2 moves the enemy. Boop. Then player 2 moves. Oh, all right. So we've got 2 enemies. Now player 1 is moving the enemy. Player 1 is moving. Player 2 is moving the enemy. Player 2 moves. Perfect. Soup's fun. Great. Got a nice turn going. Let's throw something up on the screen to let us know which player's going. You know, throw some Text Mesh Pro in there after we import it. I like Text Mesh Pro. Adds some nice tools in there. Makes using the UI a lot easier. Just it's not installed, or it's not included to start. So you just gotta import it. Takes a second. All right. Here's our team preview. Let's set our canvas. I like to do scale with screen size, right? So our canvases will scale up and scale down depending on what our screen size is. What should we shoot for? 1280 by 800? Sounds good. 1280. Ooh, excuse me. 800. Match with our height. Prefer width. And then we can go into our text. Let's put this top, middle, center. Should we get a fancy font in here? No, we'll do the font later. Center this. We'll center align it. Let's drop it down just a touch. Perfect. And let's hook this up. So this is going to be something like, you know, player one's turn, right? Make overflow. Get rid of the overflow. Where's the overflow setting? There it is. Wrapping disabled. Bam. So it'll be player's 1 turn. Player 1 will move the enemy. Player 2's turn. We can throw whatever we want up there, but we need to let our game know about it. So we're going to start getting into a whole bunch of references. Like we're going to only have one game. And we could go through the whole thing of like, oh, let's set up like a static singleton, you know, instantiation. But you know, we're gonna keep things simple, because don't let perfect get in the way of done. TMP Pro turn text. Sounds good. Rename it later. So when we start, we can say turn text dot text equals, let's do this guy. Ooh. Player. Ooh. Can't type. Player. You know, whatever player's turn. Turn, right? And we can drop in here cur player's turn +1, right? So this is an interpreted string. So you throw a $sign out there, and then using curly braces, you can do, you know, throw some variables in there, do a little math. You could do small little snippets in here. I mean, generally, you'd probably want to do something like introduce a variable, right? And just, you know, make it players number text counts, you know, something in there so that you're not doing, you know, calculations in here. But, you know, we're just adding one. So I'm going to leave it because I saved a line. Woo. And then we need to update this. So every time we go through the loop, do turns. So we update the current player, and then we want to update our text. Bam, right there. I guess we could do it. So this is going to execute, right? Boop, boop, boop. This is going to start executing here. And then the first time through, at the start of a turn, we'll update, right? And then we don't have to do it twice, right? So now just at the start of a turn, it'll tell you what the player's turn is, whose turn it is, the player's number's turn that it is, and update that text. So we can see, you know, it's this player's turn. After we do more ticking and compiling. Let's make this guy a little bigger. Get it playing, see what it looks like. All right, so it's player one's turn. Oh, we blew something up because we have a null reference, because I did not drag turn text in there. So this is one of those, you know, you got to connect those references up. There's fancy ways to do it automatically, like every time you run, but, you know, let's keep it simple. All right, so it's player one's turn. Boop, player one moves the enemy. Boop, player one moves. Now it's player two's turn. Boop, then we move the player. Player one, player two, player one, player two. Perfect. And we can update like the status too. Let's get that a little bit. Let's get a little bit fancier. Move monster, right? So we know what's going on. We're just gonna have to update this more often. So move the monster, right? And then move player. Let's get everything all nice and capitalized. Reload. I do need a new desktop, so this just goes faster. All right, so player's one turn, move the monster. Boop, move the monster. Player's one turn, move the player. Now it's player two's turn to move the monster. Boop. Now it's player's two to move the boom. Yep. Move themselves. Great. We have some movement and letting the player know. Awesome. Whew. Next up. Get an update. Telling me I'm awesome. Shows up on screen, hopefully. Thanks, John. Now the world knows you're sending me messages. Cool. Where were we? We want to... Do we want to make the board a little bit bigger to make it more interesting? Do we want to do some like exclusions? Like players can't move onto each other. Players can't move onto an enemy spot, but an enemy can move onto a player spot. Yeah. Let's make the board a little bit bigger, and then we can add a couple of like multiple starting spots. Let's say we're gonna have 4 people, right? 9 by 9 is a little cramped. So we can go into our board. How can we generate this quickly? I mean, we can't. So let's just make a really long board. It's boop, 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 boop. So we're just going to make a 3 by, how many is this? We'll figure out the count. 1, 2, 3, 4, 5, 6. 3 by 7. Thanks, John. John says hi. For all those who are here and all those viewing in the future. 6. And then 6, 5, wrong way. 4, 3, 2, 1, 0. All right, we made the board bigger. Let's check our work. Should probably turn off Slack notifications while I'm streaming. Might be a good idea. That did not work. All right. What did we break? Positions, new list. This is just a straight list, right? Boop, boop, boop. Start positions. Get open position. Oh yeah, this is it. It drops the monster in an open position. Not an open position, just a random position. All right, good job, me. Clear, highlight moves. No, why isn't it generating all these? List, positions, build, cells, dictionary, positions.count, right? So this should be, 721, right? For each position and positions. That is super weird. Maybe we didn't let it compile. Did we go too fast? Let's try it one more time. No warnings. Still running. Cursor instantiate. Let's do a little debugging. So you can do like system or what is it? Debug.logs, right? You can do like a debug log, bug log, and put some text in there, right? And it'll put it out in the console. But with a lot of IDEs, you can do something by setting a breakpoint. And you can see Rider will hook up to Unity pretty easily. So I attached a debugger to the Unity editor. And I told it, when this line executes, pause, break, take a beat. And it's going to pop me back into Rider so that I can look at, what is the current value of position? What is the current value of this? Super duper helpful because it's broken, because it's at a breakpoint. You can step through the code and you can see how the code changes really easily. Back in the day, you used to get out a piece of paper and play compiler and hand all right, this variable's this now, this variable's this now. And you can see how it's entering play mode, right? It broke because I broke it right at the start, but Ryder's yelling at me because boom, we hit our breakpoint. And we can see our current position is 002. The current cell is null, right? Because it's at the start of this line. And we can open up this and we can look at, what do I call it? Positions. Take a look at positions, right? Oh, there's only 9 in there. Why are there only 9 in there? Did I miss a comma? Am I overwriting something? What am I missing? 0, 1, 2, 0, 1, 2, 3. This is interesting. That is crazy odd. All right. Another cool thing Rider does is you have this immediate window, right? You can evaluate a piece of code. So our execution is here, right? So we're paused right here, and I can run pieces of code against the state of the application. Again, super duper helpful. So I can say positions.count contains length. Count 9. Why is it only 9? Positions. So it should be. So this is in build for each positions. So build gets called from game, right? And game just calls build. It doesn't really do anything else. I know what it is. Unity. Excuse me. All right. Unity, stop executing. So one of the super fun things is Unity will, there it is. It holds on. See, now it updated. So it serializes this data so that it stays, as data. And then only until you like go back into this and open it up, I'm guessing now that we can reset this. So there's only 9 here, right? So this is the original 9. If I go in and reset, now we have all 21. So it serialized this value, the positions value, with only 9 in it, and stored that. And because we didn't come in here and update it, so it stored this instance of the board script with the value of only 9. And then we didn't edit this. We didn't go and refresh it, even though I'm statically setting it in a script, right? I'm setting it here. It doesn't update this value. So now when I run it, because we have all 21, after we compile again, object you want to instantiate is null. Did I boop something? Current cell, prefab. All right. Now we get to do bug hunting. Object we want to instantiate. Board, game 31, board 26. Something is null. Position shouldn't be null. Transform is this. That shouldn't be null. Let's go take a look at it again. Board. These are all in here. Like these are all populated. It nuked my cell prefab. That's not fun. Where is my cell prefab? It is probably in the prefabs folder. Board. Cell. Oh, you know what? I did reset and it cleared out. So it serialized this, right? And then I hit reset and it cleared it out. Let's try this again. Excellent. More compiling. There, we got a bigger board. Now we can run around on here. Get a little bit more room to boop stuff. Run away. Stick that guy in the corner, right? Okay. Woo, that was fun. So this got us in trouble. So I'm declaring this as a member variable, right? I don't like that. So what I'm going to do is I'm going to rebuild this list every time we call build. Positions, oop, too far, equals, there we go. So now every time we call build, it will recreate this list every time build is called, not every time we mess with the inspector. So like it won't, even if it serializes something weird in here, every time we call build, it'll repopulate this. And then we can do something like, pass in the positions, like you pass in a list of positions so that we don't have to rely on this, but this is simple and easy. Let's just boop it in there. We changed a bunch of code. I'm just going to run it again because, can't be too sure. Oh, come on. There we go. All right. So our board's back, right? Now we got a bit of a bigger board. Let's do something that gets us positions, right? So we say get start position, and we just say return position 6. Let's put them in the corners. So let's say, the 0, 0, the 2, 0, like the 4 corners are going to be the positions. Let's say we'll just pass in the player number. And then we can switch. We can return switch. Ooh, what's C# version? We'll just do a switch. And then we'll do player. Right. And we're gonna have up to 4 players. Case. Wow, I cannot type. Return positions, and then this is gonna be. So this is 0, right? We're going to do 0. Oh, gosh. We're going to do 0 and 0 to 1920. Positions 0. If we're player 1, we're going to return positions. What do I say? 2. Case 2, return positions 19. Right, we got 21 so far. But this is, we're hard coding it, but that's okay. It's getting done. It's easy to modify. No, this will be 20, right? The last position. This will be 18, right? Boom, 18. So position 20, position 19, position 18. So this will give us the 4 corners. And then we can default return position 0. If ask for player 5's position. All right, you get the 0 position. But fix that if we need to. Which means we broke this guy. Set up players, return position. This is going to be player 0. This is going to be player 1. Should we have some fun? Yeah, let's have some fun. Let's do 4 players. Comma, you go there. Turn goes there. So we do insert. Nope. Keyboard. There it goes. 2, 3. All right. So we should get a player in each corner now. Do a little compiling. Thank you for the debugging accolades. It's one of those things that I'm not very confident at, but when it goes good, it's good. Cool. So, let's use our camera turning. So we've got 4 players, in the corners. Here's player 1. All right, player 2 is going to move the zombie. Player 2 is going to move. Player 3 moves the zombie. Player 3 moves. Player 4 moves the zombie. Player 4 moves, right? And then we start the cycle over again. Player 1, player 1, player 2, player 2, player 3, player 3, player 4, player 4. Perfect. We can QE. Let's all right, we got that going. Let's change gears ever so slightly. I don't like hitting QE to rotate this, so I want to change it to right mouse click and drag. You get a lot of games that you just right click and drag to rotate your camera. So let's change that. And because we wrote this all nice and bundled up in here, we can do that. How are we going to do that? We are going to use input. That's not what I wanted. Input mouse position X, right? So we're just going to move X left and right. So the X. So we're going to have to track where the last one was. Like we want to find essentially the delta. So private float last X, right? And then we're going to set up update. We're gonna let's just set it, right? So distance equals the last position minus input mouse position dot x, right? So this will give us a number of pixels that it moved in a frame, essentially. And we can rotate. We can do the transform rotate around, and instead of time delta time, we can do the distance. I have a feeling that's not going to be fast enough, but let's burn that bridge when we come to it. Do a little formatting. So now when last x, if we're moving left, right, the last x is going to be greater. So we'll have a greater number minus a smaller number is positive. And then if we're moving left, last x will be less, x will be greater. So a smaller minus a bigger will be negative. Math isn't my strong suit. Let's just try it out, and we'll flip signs as needed if we ever compile. Good times. There we go. Click. Building. Whoa! Oh yeah, we forgot a couple things, but it's sort of working. Oh. We're doing this every frame. We don't want to do this every frame. And we're never updating the last X position. So let's do last x equals input dot mouse position dot x. There we go. Now it won't fly all over the place, but we need to do this only when input dot get mouse button down. This is first frame. This is first frame. We want mouse button, and then 1 for the right click. So if the mouse button is down, this will return true. If it's not, it'll return false. Right. So we got to wrap all this up. Oh, why am I not? There we go. We'll get an extra parenthesis in there. So now only if we're holding down mouse button 1, boop, we'll check the distance right from the last X, and I have a feeling the first frame this is just gonna like nuke, like, you know, if we stop, move the mouse, start it, but we'll catch that in case later. Only when we're holding the right mouse button down, and then we'll move left and right. See if this works. All right, run. There we go. Whoop. Oh wow, it's super fast. But now if I stay still, you know, it doesn't move. Awesome. Do we have a speed? Oh, 180. Let's move this down to, well, so when you're adjusting numbers like this, it's a good trick to, if you want them smaller, half them, and if you want them bigger, double them until you get to something close, right? So like now that it's 90, you know, still going super fast. 45. I don't even know if I'm using this anymore. What's half of 45? 22-ish. Is this? I don't think this number is getting used anymore. Oh yeah, it is. Just has to be really small. So one degree per pixel. This still feels kind of fast. Let's drop it to a half. Still a little fast. 2.5. There we go. So now I can get just about 1 rotation per screen. You know, we can always, you know, stick this in a preference, and so players can update it. And, you know, everything still works. Oh, everything still works when we rotate it. But if we right click like off in the distance, you know, it does a big snappy do. So let's fix that. So now each frame we're going to update last. So last X equals input. I don't think this is going to work. So these are going to be the same on the same frame. But if we move this down to after the check, right? So if we update this after the check, the mouse essentially when we go out of scope and come back in, we'll reset the mouse position, but the last one will still be the last frame. And then we don't need to do this twice. Yeah. So now when we first click it down, right, we won't have any movement for a single frame, or at least until we move it. And then we can start spinning the screen around. Click play. Do a little holding on. Does it still do it? Oh, it's super fast. Okay, so I changed this in play mode, and it didn't stick. So I'm going to exit play mode, switch this back to a quarter, start her back up, do another hold on, and all right. See, now I can if I just click and I just click, it doesn't snap. It's only when I start moving it and holding it down. Now we have a nice, you know, I can rotate my camera left and right and, you know, move stuff around. So the next obvious thing to me, now that we have that nice feature, is we need to target the current player for the camera, right? Because I'm still targeted onto this first player. I'm not targeted onto player 4, 3, you know, whatever. Let's update those guys. Jump back into game. Each turn. So here is how we set it up. So player, we're going to do cur player turn, right? We're going to steal this guy and put it in here. So when we set the text, let's set the camera, right? This is the beginning of the turn. So I guess we could get rid of it up here. We don't need to do this twice because immediately this is going to do the turn. It's going to jump into here, right? So we don't need to do this twice. Delete some code. And then it's going to set the text to say whose player's turn it is. And that's going to focus on them. And then, you know, do the turn. Do a little build. Boop. Wait for it to build again. All right, so we're on player 1, right? We're going to move the monster. Boop, move the monster, and then move the player, and it should snap to this guy. Bam. Move the monster, move the player. Now let's move this guy. But we have to move the monster. So what if we target the camera to the monster that's moving, not the player that's moving, and just jump it around a whole bunch, right? That would be a little bit better user experience, and super easy. So instead of saying, so when we're done moving the player, let's do this after the enemy, and we can just do enemy transform. All right, so now it's going to snap to the enemy. We're going to move the enemy, and then it's going to snap to the player and move the player. Let's move this guy down. So we're moving the monster. Camera looks at the monster. We do the move the monster stuff. Look at the player. Change the text. Move the player. Do some more playing. Did I click it? Yep, I clicked it. So if you click play like too fast, like if you click it twice before it has a chance to compile, it will like compile, play, and then automatically stop, which is not super fun. All right, so we're focused on the zombie. Zombie, skeleton, one of the two. We're gonna move him, snap over to player, zombie, player, zombie, player, zombie, player, zombie, player, zombie, player, zombie. This is a great game. I could do this for hours now. Cool. So we've got it snapping. Snapping's kind of jarring, I guess. So let's lerp this guy real quick. That's a pretty easy one. So here we're setting it to the target position because we don't care what the target is. We just care like give me a target. I'll go there. So we can just do vector 3.lerp, and we're gonna say transform.position target position, and I can't remember if this should be big or small. So we're gonna make it small. Let's make it big. I think the left one is the 0 and the right one is the 1. And so we wanna move. Let's try it out and see what happens. All right, more progress bars. I'm sure there's a way to speed up like the compiling progress bar wait, but oh yeah, this is super fast. Pew, pew. I can kind of see there's like 1 frame where it's snapping. But let's move this into a variable, right? So let's make this refactor, introduce parameter, and we'll call this lerp speed, right? All right. There you go. Oh, I did a parameter, not a public member. There we go. Lerp speed. Make this public so we can change it. All right, so we've got a rotate speed, a lerp speed. This doesn't really need to be public. Oh, it does if we want to set it directly. Otherwise, we have to set do a getter and a setter, and nobody wants that. Boop. Let's jump back in here and set our lerp speed. If this ever compiles. All right, so let's try that again, but let's go a little bit slower. Let's go 95. Wait for another compile. Boop. All right, it's still super fast. So let's go the other way. Let's do 0.5. Boop. There we go. That's nice and smooth. Yeah. Now we know like where like kind of gives you a sense of like board positioning, right? So if I'm like on one side of the board and I move something, it's going to snap over and be like, oh, I know I'm over here. So let's move away from that. Nice. We can do it super fast. The camera just lerps in. Feels a lot better. We could do that with the players and the monsters and stuff. You know, give them a little boop 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 movement. But I don't think it's that bad for now. The camera thing was pretty jarring. Awesome. Oh, I'm getting hoarse. A lot of talking. So we got the camera moving. We got the players. Got the enemies. Let's do multiple enemies. How does that sound? Right now we just have, you know, generic enemy number 1. And I want to do like multiples, right? So we'll have, you know, so many players and so many enemies. I want to do like 3. Let's rename this guy. Let's rename him to where's rename? Rename. Let's name him. Is it a zombie? Did we say zombies or skeletons? Call him a skeleton. Skeleton. So there's our zombie skeleton. This is our skeleton, and let's name him that in the code. Skeleton enemy. Ooh, that's a good one. Skeleton enemy. Bam. Enemy prefab. This is actually the one I wanted to rename, but skeleton enemy prefab. We don't need formally serialized as. We just need to go reset that back up. So this is all compiling still. Go back in here, update our game with our prefab. Everything's broken. Game manager. So now we have our skeleton enemy. Drop him in there. What other enemies were we going to do? So we've got ghosts, skeletons, and monsters. I don't know what monsters is. I just imagine it to be like some big guy, right? Some big monster. Let's see if we can throw together a ghost really quick. We did the skeleton with a just blocks. Let's do the same thing. I'm gonna grab my skeleton. I'm going to break the prefab, right? Unpack, right? So now this game object is no longer linked to this prefab, right? I can do whatever I want to this, and it won't mess with anything. I guess I really need to, because the only thing this is doing is just got some cubes in it. I'm gonna leave 1 cube, and I'm gonna add a cylinder, a ghostly cylinder. Zoom over to this guy, back up a little bit. We don't need capsule colliders. Remove cube. Let's get rid of the cube. We're making a ghost, right? Make it a ghost. Delete. Let's rename him. Ghost. 3D object. I'm gonna add a sphere. We're gonna get rid of the collider on it. Oh, I forget how tall he was. Let's make this about half as tall, and then scooch this up. Right? Ooh, spooky. And we're gonna set these guys to 0.7. So now we've got sort of a ghost. Let's play and see what he does in there. Make him a skeleton zombie. So like chunks of flesh hanging off of him. That'd be cool. Where is our ghost? Slide you over. That's a not a great looking ghost, but let's make sure he's not clipping through the ground, right? Cylinder. Make him a little taller. This needs to go onto the floor, right? That guy's the floor. And then the sphere. Let's see if we can make him a more ghostly shape. Zoom in a little bit. Let's get a little stubby ghost. He's, you know, let's get a little fancy, you know. Add another couple spheres. We're gonna give him some eyes. Eyes. Boop. Don't need you. Remove component. Eyes are gonna be tiny. Scale down. See if we can give him some eyes. You know, the skeleton zombie guy gets a couple more, a little bit more geometry. Why can't the skeleton ghost? Ooh. Getting that create a file on your hard drive when your hard drive is 99% full feeling. There we go. All right. So these are going to be the eyes. Let's just give them, you know, soulless, shiny black eyes. Boop. Let's make them white. Let's go a little farther. Like, this is, you know, wait. This isn't the quick, you know, slap them together. Just make them not smooth. Super white. Drop these on there. There we go. Do we want a one-eyed ghost or a two-eyed ghost? Let's duplicate. Dupe. There we go. Slide this guy over. It's almost like a Pac-Man ghost, right? And then let's see how big he is. He should be a decent size, since everything's a 1x1 unit. Ghost is inside. Boop. Yeah, I think that works. You know, you boop boop. We're gonna jump around. All right, let's make him a prefab. Ghosty boy prefab. Get him out of the scene. All right, now that we've expertly modeled a ghost, we're gonna add him to our game. Player skeleton enemy prefab. Game object, ghost enemy prefab. Right, now we need to instantiate this dude. Same idea for the skeleton enemy. We need a reference to the instance, ghost enemy. This is probably, you know, we're going to get rid of this soon anyways, but that's okay. We're going to do this prefab. Iteratively. I cannot talk tonight. It's been a rough day. Throw the enemy, throw the ghost. So we do the move. We need to switch through these. So let's drop these guys in a list of enemies. Let's make sure he gets out there. Let's make sure he gets put on the board, moved around. After we watch a couple of progress bars. Ghost, where are you? I have an unassigned reference. Oh, I did not assign the reference. Excellent. Prefabs. Ghost goes in the ghost. Build them up. A little more progress bars. Where is he? Do you see him? I don't see. He's hiding. There he is. There's our ghost. Ooh, spooky. And we don't move him yet. You know, we're just moving the skeleton. So he's on the board. We have a ghost on the board. Excellent. Let's follow the same pattern of our players, right? Our enemies they're all enemies. They're a distinct list of entities on our board. So we can do private list, game object, and enemies. Enemies. Yes? Enemies. Keep the secret. I can't spell. Set up enemy. All right. Enemies equals new list game object. We're going to make it I'm going to say implicit list, but that's not right. It is, if you do this in Java, which I just looked up like last night, these are called like double bracketed lists, which I think is very old nomenclature. Like you do like a double brackets something. I don't know. This is C#, not Java. We don't need that noise. So we're going to do the same thing. Our enemies are going to be in a list, and then we're going to say, do the same thing. Private and current enemy, right? Current enemy equals, I'm going to start with the first one, and so should we iterate? Let's just iterate over the list of enemies, right? So the ghost will move, or sorry, the skeleton will move, then the ghost will move, then the skeleton will move, the ghost will move. This is VASK tag, all right. Trying to keep an eye on the comments, you know, the flood of comments that are happening. But if I miss something, you know, call me out. I don't know what all that's about. Anyway, back to the task at hand. Current enemy 0. We're going to do turns, and then once the enemy goes, we are going to increment the enemy. So I'm going to steal this. Should we just do it at the end, or do it right after? We'll do it at the end. Do it at the end. Current enemy equals current enemy turn enemies.count. Right? So this is gonna boop. So this means the same player is gonna move the same enemy every time if these line up. So because we have 4 players and 2 enemies, it's gonna be player 1 is enemy 1, player 2 is enemy 2, player 3 is enemy 1, player 4 is enemy 2, and then again player 1 is enemy 1. I'm okay with that for now. You know, let's keep it simple. It's just gonna be your enemy, and then we'll fix it in a minute. You know what we didn't do? We didn't pick the enemy out of the list. So, enemies, current enemy, you know, same idea. Transform, and then current, slow down like 10%. Is that like, is my buffer dying? My buffer is probably dying. Or am I talking too fast? If I'm talking too fast, like, totally call me out on it. This water really gets my heart going, so thins out the blood. Oh, I missed that. What was that, John? Getting zoomy. All right. All right. Sweet. Getting those librarian vibes going. That's awesome. We're all having a good time. Right? Right. All right. Do move current enemy, right? So now we're same idea. We're gonna move the enemy, whatever the current one is. We're gonna move the player. Let's boot back in here. Let it do its ticky thing. Double check. We got a player, skeleton, ghost. Fire this guy up. Let's see what happens. All right. First move, skeleton. Player, move the player. Second move, ghost. Second move, player. Zombie, ghost. Zombie, ghost. Zombie, ghost. Nice. Let's... What time is it? We got 10 minutes-ish. I'm trying to stick to 90 minutes. You know, I get exhausted, you get exhausted. Nobody's having fun. So let's see if we can get the random enemy pick. Can we do this quick like? I'm glad you're enjoying it, Heidi. It makes me feel good that you're feeling good. Yeah, let's see if we can slap together a quick, you know, pop up a thing on the UI, you know, show, just throw some text in the middle and say like, which enemy are we picking? Enemy pick. And we'll do like just a random, you know, slap them all up there sort of thing. So we can say like, you know, flash up the skeleton. And we can like quickly flip through like it's rolling a dice and then, you know, be good with that. And then pick that one, right? So what we need to do is we need to know the names of these, right? So the 0-1 is the skeleton, the 1 is the ghost. Let's just hard code it and we'll line them up by hand and and deal with making it more generic later. So let's see. Let's yield. We're gonna follow the yield returns coroutine, right? Because this is going to be something that's going to take some time, right? And we want to block. We want to stop our do turn until an enemy gets picked, and then we'll pick that enemy and move him. So we're going to call it pick enemy, enemy, and I've said enemy so many times, the word is now meaningless to me. Pick whatever this is, and then create method. It's going to be I enumerator. Great. We're not going to throw. Don't throw. Yield return. We'll just throw a null in there for now. All right. So we're going to pick an enemy, and say like current enemy equals, just say 0 for now, right? And return. So this is compiling. It's still going to work. Let's do a little fun thing. Let's wait like a second. Return new wait for seconds. Just wait for 2 seconds and then get out of there. But in that 2 seconds, we're gonna update that text. Public tmp text enemy pick text. Right. So when we start, we're gonna pick an enemy, right? We're gonna say enemy pick text dot enabled or active. Set active. Set act. Nope. Visible. I thought it was enabled. Enabled. There it is. Enabled. Turn it on. True. True. And then when we're done, we're gonna turn it off. So we know something's happening. So it's not always in the player's face. So we're gonna pick an enemy. It's gonna turn on that text. Wait a second. Turn it off. And for funsies, not for funsies, our configuration, like our start, sort of thing, we're going to turn it off, right, and hide it. So now we should see this skeleton disappear, reappear. I probably won't see it disappear after a frame. Appear for 2 seconds, disappear, and then do like our normal turn. That should happen every turn. All right, 1, 2, skeleton, disappear. That's a null reference because, once again, didn't set up the text reference. Boom, nailed it. Okay, progress bars, once again. 1, 2, missed something. Unassigned. Cam mover has not been assigned. Oh. All right. So we've got a little race condition going. Oh. So. So if the game, right? So we do our start and we set up our players, blah, 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 blah. We don't set the target, the camera target, until we're in here. But this is going to block for 2 seconds. So this guy's going to have to wait, right? So this is going to be null. So let's make our camera like wait and not lerp until target gets set, right? Target's always going to be set to whatever the last thing is, except for the first time. So target is not equal to null, and yes, this is a bad, like checking for null is not fast, which is what this is yelling at me. Target not null, expensive. We're only doing it once. Actually, probably doing it for 2 full seconds. Yeah, we'll be okay. If it's null, forget about it. If it isn't null, we'll move. All right, third try. Here we go. Load the bars. 1, 2. Skeleton disappears, and we start our turn. Boop, boop. Skeleton 1, skeleton 2. Next turn. Skeleton 1, skeleton 2. Next turn. Awesome. Nice. All right. One of the things that's really bothering me is this is nigh impossible to see. So I'm just going to throw an outline on there. Outline. Check the box. Turn this guy up. Yeah, I think that looks okay. It's looks kind of awful because it's so small, but what if we just crank these guys up? Skeleton. Overflow. Disable. Should we make the player one bigger? Should probably make the player one bigger. Perfect. Nailed it. Excellent. Great. So now we can see skeletons getting picked. It takes 2 seconds. And then, you know, it just says skeleton for 2 seconds between every turn. Not super fun, but let's make it fun. Because we're in a coroutine, we can yield a frame. Game. Pick enemy. So we can yield, like, instead of 2 seconds, we can just yield a frame. And let's say we want to roll the dice, and the dice takes 2 seconds to roll, right? So var roll time equals 2f, right? 2 seconds. Let's say while roll time is greater than 0, we're going to yield. Yield return null, right? Don't need this guy anymore. Also, make sure you roll time minus equals time.delta time. So time.delta time is like the current frame, right? Yield return null is like, come back to me next frame. And then time.delta time is how long the last frame took. And it will just increment this. So this is essentially going from 2 to 0 in 2 seconds. So it should be, 1, 2, off it goes. It's so we can yield each frame and not just block on a single line. We can do some work. But it's the same, essentially the same functionality. We can do something like setting the text. Enemy pick text dot text equals, and then we'll do the whatever the names are. So let's set that up here and do nope, not up here, way up here. Enemies. Let's do private list, and we'll just do strings. Right? Enemy names. I'm being very inconsistent with my naming or my capitalization. Right? Lowercase. F6. Lowercase. There we go. And then when we start up, here we set the enemies, and let's just do enemy names equals new list. Get rid of those guys. And because we're right here, right, we know the first one's the skeleton, the second one's the ghost. We're going to say skeleton, and ghost. I can type and spell. It's a double threat. So now we can say text equals enemy names, grab an index and just do random in a range. We could say 0 to enemy names dot count. Right? And because this is 0 inclusive, min inclusive, max exclusive, this should be just fine. But I want to retain whatever number this is, because the last one that shows up is the one we're going to pick. So var cur pick equals, just set it to 0. Let's say cur pick equals, I'm going to grab this guy out of here. That is not what I wanted. I wanted the whole thing. X V colon. We're just going to grab the cur pick, right? And then we can do, so once it's done picking, we want to wait a little bit. New, wait for seconds. We'll give the player a whole half a second to look at it. All right, so we come in. We're gonna wait 2 seconds. Let's drop this down to 1.5. We're gonna wait 1.5 seconds, and we're gonna just randomly pick. Flash them up there every frame. And then after that, we're gonna stop and we're gonna pick those last 2. So now we need to figure out a way to get this current pick, back out. Right? Oh, it's yelling at me. This doesn't need to be initialized. Just need to int. this just needs to be initialized. So getting data out of this is just going to be the same, set a member variable, int cur enemy. Oh, did we do this? We did this already, right? Current enemy. I don't think that'll break anything reusing it. That's what it's there for. So we can say current enemy, right? Because those should line up, right? We're going to display the enemy names current enemy. Don't need you anymore. Don't need you, because this is going to already get set, right? It's going to randomly pick one. It's going to do, right? As we do the turn, it's going to pick an enemy, and it's going to fill the current enemy with the index of whatever the current enemy is. And so we can even do fun stuff with it here. Move enemy names current enemy, right? So now we say player 1 move skeleton, player 1 move player. Hopefully this works, or it's going to look silly. We're 3 minutes over. Thought it was going to take 10. Hopefully it took 13. Take a little drink. Go skeleton, go skeleton. All right, cool. We move the skeleton. Skeleton go, skeleton ghost, skeleton again. Are we ever gonna get? We got the ghost. All right, so that flickers way too fast. So let's slow it down a little bit. And we can easily do that by where we go? Update pick enemy. Instead of just yield returning null, we can return a new wait 4 seconds, 10th of a second, so it'll flash 15 times instead of, what is it, 45 times. That sounds reasonable if we're running 30 FPS, right? 1.5 seconds at 30 FPS, 45 times. Get that loading bar going. Reload again. Go skeleton, go skeleton. Now it's just flipping. Still flipping. Go. I probably broke some. There we go. Move the skeleton. See, move skeleton. Skeleton. Player. Flip between the two. This feels like it takes a really long time. Oh, because it does. So one of the things we did, because now instead of waiting a single frame here, we're waiting multiple frames, and this is still the single frame. So this gets updated every time this returns, like over a whole 10th of a second. So this can just be, now we know how long we are waiting. So as long as these match up, right? So let's turn this into a variable real quick, because I want to mess with it. Replace two occurrences are select time. Right? Let's move this guy up. Format. So now select time, it'll wait for select time and then subtract select time from our overall time, which gives us a nice result, hopefully. If it ever plays. Oh, I clicked it again. It's going to play and stop. Oh, it didn't. Yay, skeleton. All right. Do it one more time. Go skeleton, flippin', pick the ghost. All right, so now it's like, oh, did it stop? I'm not sure if it stopped. Let's tweak it one more time. Let's change the selection time. So like when roll time is high, right? When it's close to the top, it'll be fast. But then when it's near almost done, it'll slow down. So we can just say bar current select is equal to roll time divided by, not select time. Will that get bigger or smaller? That'll get smaller. So as roll time goes from 1.5 to 0, this will go from, several seconds. That doesn't. So like, let's say roll time is 1.5 divided by 0 0.1, right? That's 15. Math. Yeah? So this is the first time it's going to wait 15. Let's not do that. Let's do selected time times roll time divided by times roll time. So the first time it'll wait 0.15, and then a little bit less, a little bit less, a little bit less. That sounds... Let's give it a try. What the hey? Math is not the strong suit. Also, I think this is going to be probably the last feature we're going to implement tonight. Thanks for hanging out and chatting with me. It's a good time, even though I lost my voice. That wasn't... and I'm going to want to fix this. I'm going to want to fix this. Yep. I do not like that. That's going to bother me if I don't fix it. All right, we're going to fix this, make it look nice, and then we'll be done for the night. So one of the cool things we can do with Unity is drop a curve in here so we can visually see like how long this thing is going to take. And those things are in animation, curves, show selection time. Right. Grab this, go back to select enemy, or pick enemy, right? And we're going to wait, not select time, but show selection time dot evaluate, and then roll time, right? Let's do roll time's decrementing, and we want this to be, we want to convert this to a 0 to 1. So we'll say like our total roll time equals roll time, right? So we'll set that to the same, and we can say roll time divided by total roll time, right? So this will go from 1, like the first time through, down to 0. And let's do 1 minus, just for, I want it to go left to right, so 1 to 0. You may have to flip that. But now we get, if it ever loads, a nice GUI that is set up for us. So we have this show selection time, and we can open up this really cool curve editor. So you see it goes from 0 to 1. Okay, so I did have it backwards. 0 to 1, so at 0 we want it to be a little bit, and at 1 we can select this. At 1 it'll be up. Let's make this guy edit key. Let's make the value 1. No, not 1.5. So the last time this shows, we want it to be 0.1, right? And then we can smooth this out. Let's see if we can. It does look like really tight, but let's see if we can zoom in on this guy. Zoom. Nope. All right. So it's gonna increment. It's gonna go up. There we go. Just had to exit out and come back in. So it's gonna increase. Let's see if we can turn the strength down. Left tangent. Is it free? I don't know. Either way, we get this nice curve. So like at the beginning, they're going to be very short increments, right? Boop, 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 boop. And they're going to slowly get longer until we get to the last one. So it's going to look like it's slowing down. Do you know what I mean? This is more of a exponential curve than a linear curve. But then, so as we select like the 0 all the way up to the 1, which means we do, where'd it go? Roll time. So when roll time is 1.5, total time is 1.5. 1 minus 1.5 is 0. So it starts at the left time of that graph and then goes up to the right side. All right. If this works, we'll be done. Gonna hang out and chat for a few minutes. But my voice is going. Yeah, it does a little flashy flash. Let's see if we can make it more obvious. So let's make roll time like 3. Now it'll be more obvious. Do a little compile, a little clicky click. Oh, this is... What did I do? I broke something. Oh, I double clicked play. Here we go. This is it. Now's the time. Skeleton... I don't know. Yeah, I mean, it sort of slows down. Yeah, let's say good enough. You know, let's not let perfect get in the way of done. I mean, it's done, and it could be better, but let's call it there. I feel good about that. Yeah. So that's it. That's how we do. Making most of the board game. I think next week probably work on graphics a little bit. I know like you get that nice visual buy-in, right? So if it looks nice, you feel better about it. This is kind of plain. Do a little bit of updating. Make the skeleton look nice. Make the ghost look nice. We'll add a monster. Maybe build out the board a little bit. I think that'd be fun. I know we don't have a lot of the game logic in. Maybe we could focus on that. But you know, it's getting there. We got multiple players, multiple monsters. Got some UI action going. UI is probably one of the things I like the least in Unity. It's just a little magic when you get into the more fancy stuff. But if we can keep it simple, I think we'll be all right. So yeah, next week we'll either build out some fancy graphics, or you know, put in a little more game logic, like not letting players move on to enemies. Cool. So if you liked, you know, let me know. If you found me through Twitter, let me know on Twitter. You got to get those engagement numbers up. But also, you know, if you enjoyed it, subscribe to the channel so you know when I go live. I'll try and post a little bit more heads up. Had a little bit of a life gets in the way tonight. So next week, Tuesday, hopefully 7:30, unless we have problems again, but 7:30 Central Time, and we'll do a little more board game dev in Unity. Maybe even open up Blender for a minute. Wouldn't that be nice? But thanks again. Have a great night, and see you next week.